Okay, this is Algebra 2, Lesson 3. We talk about a numerical expression. Basically, it's a meaningful arrangement of numerals and symbols that designate operations. So, for instance, each one of these is a numerical expression. This stands for 4, 2 plus 2 is 4, this equals 4, this equals 4, and this equals 4. So every numerical expression represents a single number, and we say that that number is called the value. A numerical expression is also an algebraic expression. An algebraic expression can contain letters that represent unspecified numbers, which we call variables. So let's look at this first one. If we do x plus 4, we have an algebraic expression. Okay? X stands for some value of some number. If we replace x with negative 32, we now get 28. By doing this, we've said we've evaluated the expression. So, for instance, let's do this first example. Let's do x squared y minus y if x equals negative 2 and y equals negative 4. Well, x is negative 2, so you have to do negative 2 squared. Because you're replacing this into this, that negative goes inside the parentheses and it is square. Y is negative 4 times a negative 4 minus, you cannot forget that negative sign, and then y you replace with a negative 4. So now we just simply are going to simplify it. Therefore, we're going to say negative 2 squared is like negative 2 times 2, which is a positive 4, times a negative 4. You have two negatives here. This is an implied negative 1 times a negative 4. So what do you have when you have negative times negative? You have a positive, so it's positive 4. Here, I have 4 times negative 4, which is negative 16, plus 4, and my answer is simply negative 12. You go back to using your please excuse my dear Aunt Sally, which is your order of operation, then you use your integer rules here when you're doing a negative plus a positive. They're different signs. You find the difference between these two numbers. You look to see which is the bigger absolute value, which is 16, and you keep that sign. Okay, now let's talk about like terms. What are like terms? Like terms are terms for the same variable that are raised to the same power. For instance, let's look at this one. Let's see if this is a like term. This is a z, and this is a 2z yx. Do these look like terms? Well, a lot of people would say, no, that's not a like term. They're different. They look different. Okay? In a term, you have to look at the variable or variables. You ignore the coefficient. Don't forget, coefficient is the constant or the number. So we ignore that. It doesn't matter what that is. It doesn't matter what sign, positive or negative. You look at the variables or variable. Let's write them down here. X, Y, Z. Well, they don't look like they're the same. So most people would say they're not like terms. But let's give them a value. If X is 1 and Y is 2 and Z is 1, let's replace these values in each example. Okay, you have x is 1 times 2 times 1. Then you're going to get 1 times 2 times 1 gives you 2. Here, you've got 1 times 2. You replace them with the same values. You multiply them out, and you get 2. They are like terms. They are just in different order. And if you remember, we had the commutative property of multiplication, which says 3 times 4 is also equal to 4 times 3. You're going to get the same value regardless of the order. Therefore, here you have the same variables raised to the same power. They're just in different order because of our commutative property. It says we can do that. They're still the same. However, if this was square, this now becomes 1 times 4 times 1, which is equal to 4, they are no longer like terms because you get different values. Alright, so let's do an example of like terms. When you have like terms, then you can add or subtract them. You simply combine the coefficients. So let's look at an example of one with like terms. And just like you have a commutative property of multiplication, you also have one for addition, which says you can rearrange the order. So let's look at this one. That looks a little complicated, doesn't it? How am I going to do that? Well, the first thing you have to know is you have fractions. This is still a fraction, just a complicated fraction. That's a fraction. That's considered a whole number and a fraction. Just complicated. So what we want to do is we want to make all our exponents positive. And we learned in the previous rule that to make the exponent positive, you have to do its reciprocal. So, therefore, the reciprocal of a is 1 over a. So this now becomes 3b. A moves to the bottom, and the exponent now becomes positive. You keep that exponent number, except for the sign, you do the opposite sign. These are all positive, so I can leave that one. Then I've got 7, whoops, a to the negative 2, so that's a over 1. Its reciprocal is 1 over a, so it's going to go to the bottom, square. C to the negative 1 is 1 over c, and it's to the first power, it's implied, so we don't have to write that 1 there. Minus 4b a squared c. Okay? What do we know about fractions? In fractions, you have to have the same denominator. Yes? So, are these like terms? Yes. A squared c, a squared c, a squared c. This one isn't, so this one can't be added or subtracted to these 3 terms over here. So we're going to look at these terms. And how do we add or subtract fractions? You have the same common denominator. Then you combine the numerator. So you simply have 3b minus, you can't leave that minus sign, plus 7b all over a squared c minus 4b a squared over c. Yes? So now, in this numerator, we can combine. Do we have any like terms? Remember, we said like term says a term with the same variable or variables raised to the same power. You have a variable of b to the first, b to the first, and b to the first. These are all like terms, therefore I can combine them. If you look at the coefficients, you have a positive 3, a negative 4, and a positive 3. What is 3 minus 4 plus 3? It's going to be 6. So you simply have 6b, you keep that variable or variables, and you have a squared over c minus 4b a squared over c. And that is simply your answer. That's as far as you can reduce it. Alright? So the key to like terms is they have to have the same variable or variables raised to the same power. Then you combine their coefficients, and the coefficients are the constants. Alright? That's it for this lesson.